Hello and welcome to this little tutorial about BPMN intermediate events. I'm going to be including start and end events in that. And today I'm going to go through the main probably events you would use in order to do things in your process, and why to use them and how to execute them. We'll take sort of the main ones in detail, and then at the very end I'll throw in a little bonus section where I'll go through a bunch of the other ones to discuss those as well, and kind of again very quickly why you might want to use those. For each one, obviously, I want to discuss how to model it. I want to discuss how to use it, when to use it, some patterns there. And then also I'll show execution, how they actually run and how they're actually implemented. We'll start off actually with this. These are the sort of the I would say the plain vanilla version of events. We have a start event which produces a token, we say, which is the start of the process. We also have a milestone. This just basically says, hey, I was here. This is a thing that's useful. These are actually pretty handy for things like reporting. You might want to report between two milestones, how long something takes, that sort of thing. And we also have intermediate events, which are exactly the same as milestones, but have a weirder name. So these are the same thing, but they're just called either milestones or intermediate events. This is actually called intermediate non-event, but I decided that's just too much. Then we have an end, we have an end event, and this consumes a token. Doesn't end a process necessarily, although often it does. But if the last token enters an end event, the process ends. But this end event just consumes a token. So if we say token simulation, we pass through here, we go here, token's gone. Great. Now, if you want to do something more interesting with these events, like have them have additional functionality, you just need to select them and then select up here for change element. What that does is it gives you a list of additional types that you can add to this. They always keep their initial features, so start event will always produce a token and an event will always consume a token, but they can do additional stuff. And that's what we'll be talking about today. The start event, you can see, has some stuff here. The intermediate event has a bunch of other stuff, a lot more things, and the end event has slightly different stuff as well. And we'll talk about why that is. So yeah, let's get started. Our first event is the timer event. Now the timer event can be placed on either a start event or an intermediate event, and it's pretty straightforward to do that. You select your start event, go here, and you'll see timer start event is right there. So the timer start event works by basically saying this process, while it can be started manually, is also started on a specific, usually cycle, a specific amount of time. Very common use case for this is if you wanted to do a bunch of batch processing at the end of the day, you might want to have a start event there with a timer that like triggers at like midnight on a weekday or something. That will then kick off that process and then do a bunch of stuff. And that way you don't need to worry about it. The engine takes care of when to trigger it. Now, then we also have the intermediary timer event, and this actually is quite different. While this thing usually tends to work on a cycle of like every day, whatever time or whatever, this thing here will only trigger once, right? So this thing here might be like every midnight. This might be something like a duration. So let's say it might say after 1 hour. Then trigger. So this could be all sorts of reasons for this. This could be like you have a task in here that basically does something like, let's say, reserve tickets, and then after an hour you'll like send those tickets, like process tickets. And so we're waiting from reserving to processing for various reasons. And the way that would work would be we start our process, which is going to be in a second. We start our process. There we go. We reserve our tickets. Then our token waits. As soon as we get to this event, the hour starts, right? So the hour starts the moment the token arrives at the hour. And from that point, it counts down. And then we go forward. Great. But the interesting thing about intermediate events is they don't necessarily have to be so strict about after an hour, right? So what if like you might want to mail the tickets, but you don't want to mail the tickets immediately. You want to mail the tickets, let's say, a month before the gig you're going to go see. So intermediary events can actually work with variables as well to say something like 1 month before. So that way they can reserve their tickets like a year in advance, but you don't want to mail it to them immediately. You want to wait for about a month before the gig in case maybe the gig gets cancelled or something, and then you mail the tickets out. So it can use variables in the process as well. So those are all pretty good use cases for timer. Now let's talk about implementation. For that, I'm going to go into the Implement tab here on the top right, and now we can see some fun little X's here that indicate that stuff needs to be done. So, and that can be done by editing the panel here. So if I select the start event, and I can see that we have a timer type. Now, as I mentioned, cycle is the most common. You can also have a specific date you start on. That's not very common, so I'm going to skip that. So cycle is basically a reoccurring cycle that may happen. And this needs to be done in a specific standard called ISO 8601. And this is a standard for determining durations. It's actually really, really easy. So for instance, if I wanted to wait, let's say every 12 hours, we would say repeat. So R for repeat, then /, so period, which is, if we wanted like 12 hours, we would say period and time, and then we would say 12, and then we would say H. So now what will happen is this thing will repeat every 12 hours. We can also maybe do 1 day. So maybe we can say P1D and then T5M. And what this does is it says, let's repeat every 1 day and 5 minutes. So the fullest you can make this would be, you could say period, 1 year, 33 months, 4 days. Then we put a T in because now everything after this is smaller than a day. So then we have maybe 4 hours, 88 minutes, 22 seconds. So what that does would be, it would say, great stuff. We are going to calculate when that is in the future, and then we will trigger at that point. But if you don't need most of those, then you just do what I said immediately, which is P, no day, no month, no year, straight to T. Then we do a 12 and then H for hour, and then we repeat every 12 hours. Pretty easy. Now if we move on to intermediate events, they're a little different. We don't really have a cycle here because this can trigger multiple times, and it will, but this will only trigger once. When the token arrives, it'll wait for a set amount of time. And we do have two options here. We have a date and we have a duration. And in duration, it's exactly the same. We give, except for the R. So we have PT, let's say 5M, right? So wait 5 minutes. And we also have our date here. So our date could actually be, I say, a manipulation of a variable or an existing variable or all sorts of stuff. And we do have like a bunch of expressions in feel that will allow us to do that. Now to do that, you would need to click here. And assuming we already have a variable called like gig date, for instance, we can then just say add to that. You can say duration, and we can say, then we use it ISO 8601 again, P1M. There we go. So gig date plus a month, and that's how long we're going to wait. So yeah, that's how that works. And yeah, very, very common use case, probably the most common event to start with. But next we're going to go to probably the most useful event, I think, for multi-process communication. So let's do that next. We're back on this model where we have our start event, intermediate, and end. And now I'm going to talk about how you use message events with these. Now, timer events were only used for start events and intermediate events and not for end events. And that's a very good reason for that, because timers are always what we call catch events, which is an event that is waiting for a specific thing to occur, which is time expiring. There's no way to produce time. It just passes along. It's a very existential idea, but trust me. But message events can both be sent and received. So you'll see that that message events can, in a start event, are always catch events. Okay, that's why they have a white envelope. And the catch events, the catch equivalent, looks like this with a black envelope. So this means that this will catch, this will send. Okay, and in intermediate context, you can both catch and send. Start and end events, obviously, because they produce tokens or consume tokens, this can only catch a message, so it starts a token, and this can also send a message so that it consumes a token and sends off a message. And in the meantime, we can do all sorts of stuff here. Now, message events in BPMN are very specific in the sense that they have rules that guide them and why they're being used for. The first most important thing is that message events are used for inter-process communication, which means communication to other processes or other systems in some cases, which means a message event, when you have, for instance, a send, must be to a different process. You cannot send a message to yourself. Same, which is why you can't catch a message that was sent by the same process. There's better symbols to use for that anyway. But basically, anytime you see a message event, it should be showing specifically communication externally. The other interesting thing about message events are that they need to have a one-to-one correlation, which means if you send a message, it must arrive at exactly one recipient that must be waiting for it, right? Or else it's failed. It can't arrive to find 0 recipients or more than 1. Otherwise, it's a failed message. And that's what the BPMN standard tells us. On a technical level, you can kind of miss that around a little bit. You can kind of break the rules. But if you are modeling purely for understandability of documentation, then you should keep those rules pretty strongly, because they do indicate a lot by just one symbol, and it's important to know that. And there are other symbols to do other things, but message events, one-to-one correlation, and always external to the process. So now let's talk a little bit about why you might use them. The key thing here is for scoping mechanisms. A lot of processes exist in a specific scope, and there's loads of ways of breaking up that scope. When I say scope, I mean a start event and an end event define what the scope of a process is, what state exists before we begin, what state we want afterwards. And that's nice and contained. But the truth is that, of course, end-to-end processes, or like high-level ones, go much further than that. So they actually may stuff may happen way before this process and stuff may happen way after. And one of the best ways to maintain sort of a decoupled strategy for maintaining multiple models across a true end-to-end is by using message events to define scope. So when my process ends, I'll send a message to the next process, and whatever that does is not my responsibility necessarily. That's out of scope. So I can send a message and my process can end and then do the next one. And that way you can maintain that quite easily and have both a way of actually tracing your process end to end while also maintaining separation. The intermediate ones are used very commonly if you have two different processes that need to let each other know when you're finished a certain point. A very common thing might be for you sending a message to, let's say, an onboarding customer to do a background check. Then we would wait here until the background check is complete, and depending on the response, we'll do something. So those are two different scopes as well, but they're running in parallel. So that's basically the way to think about message events. Now we're going to move on to probably the most complicated part of message events, which is execution. So let's do that now. Now moving into the implement tab, we have these 4 big X's. Now implementing a receive message is very easy. Send is a little more complicated. So with receive messages, you see that we have predefined messages that have start cool process, right here. And what this says basically is that we want a message to come in with the name start cool process. Now with start events in particular, you're only allowed to have one message name per start event deployed to the same place, because it needs a one-to-one correlation. So only one start event can have this name. So when you send in a message, it'll always start the same process, which is quite handy. That's not true of the intermediate events, it's just true of this one. And so this you can see as a correlation key to ensure that only one is matched. If we look at the intermediate event, it's a little different. So here we have super cool process. Now we do have the name, but because it's possible to have lots of process instances all waiting for this message, we also need a correlation key or a subscription correlation key here. Now this is the extra bit of information that helps us find the specific process we're interested in. So we could send super cool process a message, right? But which of the 100 instances do we want? Well, it's the one that shares the order ID with the message that comes in. Now for this, it's a little more complicated. For that, we're going to need to make an API call. We're going to make a REST call. And you can see in the docs here that we have this REST call. And I've already deployed a process with a start message event and an intermediate message event catch. And we are going to play the role of the send. Because as I mentioned, in most cases, you are sending from external sources. It's also implementable in the model as well, but this is like how an external system might communicate. And I've already got my lovely Postman instance here. You see here that we have our message publication. We have our name, which is the start event. We're sending in a variable called name, which is Niall, and our correlation key is also Niall. And we're going to send this in. This should start a process instance. So if I send this, great, we've got a 200 OK in the bottom there, which is good news. And now if I go to my process, I should refresh this and I should see that we have an instance waiting. So we see here in this instance, it's waiting for the new message. It's got a name, which is Niall, and that's our correlation key, is name. So if I go back here, I now am going to change this to continue process. And its correlation key is going to be Niall. So we see here that that should be all right. And we're going to throw in a new variable, new name, and that's going to be laugh. And let's send that. Also got 200 OK, which means that if I refresh this, there we go. Okay, so that got found, and we see that the new payload is right there. Okay, and that's basically how message sends work on a fundamental level. The final event we're going to focus on is going to be the signal event. The signal event is also an event that can be both a start event and an end event. And it can also be an intermediate event in the same way that message events as well. And they have a lot of similarities to message events. They do send communication to other processes, but they don't have the same restrictions. Right? So message events, as I mentioned, are one-to-one correlation. You must send outside the scope of the process, blah, blah, blah. And these do not have those restrictions. These are a broadcast. They are sent to 0 to n users. Any amount of recipients can get these, including your own process. So they don't have that limitation at all. And so the scope is every single process and every single process instance, and the requirement on a number of recipients doesn't exist. It can be any number, including 0. So that's why this is kind of an interesting one, a little less restrictive than messages. There are ways in which you can make it more restrictive, and I'll talk about that. So some of the use cases for message events are pretty obvious. With the start message event, a signal event, this, unlike a message event, can have multiple processes all started by the same signal, right? And this is really, really handy. I talked about an example a little while ago about a timer event that would start and it would like do all sorts of like data calculation at the end of the day. Well, this was a real case that I came across a couple of years ago where they had all this data. They needed to like do a certain amount of processing on the data, but once it was finished, they wanted to kick off a whole bunch of different reporting processes that worked on that data. Now, it was unclear exactly when the data would be finished processing, so it could be maybe 15 minutes, it could be 45 minutes, it could be an hour. So you couldn't use a timer event for that. So instead, they used a signal event to, first of all, broadcast at the end of the data processing, we're done now. And then all of the processes that created these reports were all started by the same signal event. So they all started in parallel as soon as it was over. And this is a really good use case for a start and end event for triggering other processes. In terms of sending intermediate events, this is really handy for things like if you wanted to, let's say there's a customer who has lots of, I don't know, policies with, you for whatever reason, and they've done an update. It's a nice idea sometimes if a process is waiting for not quite complete, that you can then send, let's say, a signal that's triggered that waits for all currently running instances of that person's policy and then updates them. So that way you can catch any number that are running. If none are running, no problem. If there are 20 running, great. So it's a way of being able to trigger existing processes that are all dealing with the same entity, but at different times, and they're kind of very loosely coupled. Now, implementation wise, this is much easier than the message event because there's no correlation keys required. So you can see that here we have a signal that's required, and that might be start report. As I mentioned, this could be any number of start events could have that same start report signal, and it would trigger that. Also a bit dangerous, you need to make sure that you haven't accidentally duplicated a signal that already exists because it will be triggered. The next one here is a signal send, and this is kind of interesting because this could be something like, let's say, user data update. Now the reason this is interesting is because we could also have exactly the same thing here, user data update. And the problem with this might be that, hey, I don't want to update every single user, just the ones I want. How would I do that? Well, you can kind of secretly put in some correlation stuff in here. And you can do that by clicking right here to make this a field expression. So you could say that the name of the signal is a hard-coded value, right? Like user update. And then you can do is you can, in runtime, add user ID. Right, so now the signal's name is whatever correlation this is, and then this thing here will pick that up. Now this really limits the amount of recipients, and this is a really nice way of being able to ensure you get a lower correlation in those. Okay, so next up, let's talk about a fast-paced going through the other really cool and interesting intermediate events. Let's get going. Okay, let's run through these super fast. Bonus episode, other events. First things first, we have conditional events. These are events that basically wait for a specific condition to be true, and once it is, you start. So you see here, we have the example of value of stock has decreased. We go ahead, we buy the stock, we then wait until the stock has increased in value, and then we sell the stock. This could, just like a timer event, this is a conditional event, and it usually like evaluates a local variable in the context. But that's basically how that one works. Next up, we have link event, which is a really interesting one. A link event is basically a go-to. So you can see here, there's a catch, there's a throw. Link events are often used if you have a very, very big model and you need to go from one place to another, but putting a sequence flow across it would really ugly up your model. It basically works like a transporter for a token. So we start here, we do the important work. If we need to try again, then we go down to the signal event, and then that triggers it and we do it again. And then if we don't need to do it, great stuff. So signal event is quite nice. You need to transport a token within the same process. You can use a signal event. Moving further down, we have a terminate event. Super, super handy. Terminate event works by basically saying, unlike a usual sort of process where or an end event, where if a token arrives at an end event, it will consume the token, the process is still running and everything is fine. A terminate event basically says, if there is any other tokens in the scope, destroy them. Boom, they're gone. So this will always destroy all tokens in the process. It won't necessarily end the process because this could be scoped within a sub-process, which wouldn't kill any tokens outside of that scope. So do remember this is about scoping. And then I would be remiss if I wasn't to talk about the thing that you can now use to wait for multiple events, which is, as I mentioned in the previous video, this is the event-based gateway. So all the events you heard me talk about, all of those intermediate events, they can all be sort of chalked up together using the event-based gateway. In this case, we see if a message comes, timer, condition, or signal, whichever one arrives first, then we go that direction. Very, very handy if you're waiting for multiple things that may happen at the same time. Great stuff. Hope you enjoyed that. There's some events we did not talk about because we'll talk about boundary events later, and it's better to scope those. So things like error events, escalation events, and compensation. I'll talk about those in a separate video where we can talk more about boundary events and sub-processes and stuff. So hope this was useful. Talk to you again soon. Cheerio, bye.